Assalamualaikum and good evening, everyone. Please scan your QR code while we're waiting another like 2 or 3 students. Please make sure also you turn on and enable your webcam. Okay, Assalamualaikum and good evening. I guess we already wait another 5 more minutes for your old friend to join us. Okay, this is basically first class for your DL, which is last previous class we just like get to know each other. And in our previous class, I already informed all of you that the requirement for my class is you need to enable your webcam. If you have any problem with your webcam, please join using your phone to enable your webcam. And please make sure that you help me also to make this class more fun, and then we're going to have like session sharing instead only one way communication. Whenever I like teaching, and then you can just interrupt me like to ask any question. No need for you to raise hand, no need for you to chat in the chat box, which is I already closed that section. You just interrupt me and ask me any question, or maybe you just want to share any kind of stories or any kind of idea, whatever you want to share to us. So you are allowed to do so. Now, at the very beginning, today we're going to look into our module 1. And this module 1 is quite boring for me, of course, because it's more like theory. For the rest of section 3 and section 6, which is we already go deeper into our session, our module 2, and that module 2 more like interactive because it's have the mathematical equation, mathematical method. So we play along together on the mathematical equation. So now, before I can proceed to further, I do believe that this is your second weeks. So last week we have an holiday for our Wednesday class. I just want to know what you do and what you did uh, when you have like free time. So let me ask you, Muhammad Imtia. Imtia what? Muhammad Imtia. Because you did not enable your webcam, I want to ask you a question. Are you here? Muhammad Imtia. What is your full name? I cannot see. Muhammad Imtia. Muhammad Imtia, are you here or not? Okay, I already kicked him from this class. This is what I'm going to do. If I call you several times and there is no reply, you will be kicked. Okay. So next person, Nabil. You also did not turn on your webcam. Nabil. Nabil?
Yes.
Okay. Why you did not turn on your webcam?
Oh, wait.
Okay. So while you are turning on your webcam, I want to ask, what is basically personally on your, maybe you already read or not, the differentiation between analog and digital? Tiba-tiba semua nak buka nota kan? I forgot to scan QR code. Nabil? Chun Tae Yo.
Yes.
Okay. Personally, as like maybe your opinion or maybe your knowledge, what is the differentiation between analog and digital?
Analog and digital. Digital is like discrete number, like binary system 0 and 1, and analog like uh, it's like the value on the graph in the graph. Something like.
Okay, thank you. So that is like your point basically between analog and digital. Nabil, your answer? What is digital?
I'm struggling to open my webcam. Wait.
Okay. Terus hilang dah. Okay, Nabil.
Hello.
Yes.
Can you repeat the question?
What personally, and maybe your opinion or maybe your knowledge, what is the differentiation between analog and digital?
Um, I'm not really sure.
So what are you doing last week? Okay, so let me start our first of all in our siapa nak masuk ni? Tadi yang kena kick. Ada. Okay, let me share my screen now. Okay, first of all, before you go deeper, although you're going to learn on digital logic, but you need to know also like a basic thing before you can go further. So, digital have the Varfusa, which is on the opposite of digital is analog. And now in this first beginning, more on theory or more on a basic knowledge, you're going to learn on digital and analog. So similar to what your friend answered just now, you're right. So he did mention digital on discrete. So that is another keyword. There is a keywords that's stated by him. And before we can see what is digital, you can see this is on analog. Analog is mostly it is continuous. So this is the example of signal for analog. Why I said it is continuous, because you can see that there is no maybe something that stop over here or pinch, but it is continuous. Every second it will be have a value. Every second, let's say I ask you, what is the value of temperature at 6:30 second? So maybe we will like draw this. This one you already learned in mathematics. So you will say, okay, this is the value of temperature at 60:30. And but if you compare to digital, the value is discrete. And discrete mean it is discontinuous. You will only have the value at certain time or period, and in between you don't know what is the value. You cannot like just assume. You cannot just make assumption, because sometimes, let's say at the over here at 2:30, sometimes maybe the temperature is suddenly drop because it's raining, so you don't know. So the advantage is like maybe continuous or analog, you have all the value in every period. So the big and the first differentiation between analog and discrete is continuous, and another one is discontinuous, or you can call as discrete. So that is the very first differentiation between digital and analog. Okay, now you can see over here what type of question and how the question can ask you. So question can be asked in terms of multi-choice question. So you will given A, B, C, D. So you need to pick the correct answer. Maybe what is the definitions of digital, and maybe what is the definition of analog, and what is the differentiation. So all of this you need to know. So move forward. This is another big differentiation, the table of differentiation between analog and digital. So analog normally is going to be used as a base 10, but digital will be used as a base 2. Later in next module, which is module 2, you will going to learn on numbering system. So this numbering system you will learn on base 2, base 10, base 8, base 16, and etc. Basically, you can have 3, 4, 5. The rest of the base is depend on the question itself. And over here, on the differentiation between analog and digital, you can see that if you have base 10, you're going to have 10 digit or 10 possibility to represent your value is 0 until 9. So altogether we'll have 10. 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, sorry. So altogether we will have 10. And if you have best 2, you only have 0 and 1, and the possibility of numbering to be used is 0 and 1. Total is 2 digit. Let's say I have best 3 number. How you going to represent is using 0, 1, 2 only. And if you have like base 4, going to have 0, 1, 2, 3. But later on you will learn all of this. And you can see analog system is a combination of device that manipulate value, represent in analog form, while for digital system is a combinations of device that manipulate value of representations in digital form. I don't like basically to remember, as long as I understand what is the differentiation, how this look like, so then I can like easily to understand it. But sometimes you are different type of person, you need to like reading to be understand on something, so you can try to read by yourself. So this is the example. You can see this is the example, similar example, analog version, which is continuous. But for this one, you can see the value is changing. You can have like 1, 0, 0, which is still in the range. While for the digital, you're going to have only 0 and 1. And in between, there is no casting like 1.1, 0.1, 0.5, 0.6. No. You only have the value, either it is 0 or 1. So you can take a look over here. And 0 can be also called as something like negative, because we also don't want to get 0 in our exam, right? So it's like negative. It will be also can call as low. It can call also as off. What else? It can be also called as false. As mentioned previously, you have a lot of lecturers. Sometimes your lecturer like, okay, I love to use off. Sometimes in next question, the lecturer you love to use low. So as long as you know that all these negative terms is the same meaning with 0. And while for the value of 1, it also is like positive, and it is high, on, and another one is true. So you can have any possible way for you to be asked in a question, because sometimes it's just saying, okay, that pulse is on state. So you need to know what is on. And now you can see over here, this one is analog, but inside of this, you might also have the digital, but the value is only at the specific time. And the example over here, the one extra here, is for you to see how you can have the possibility for you to convert from analog signal, you want to convert to digital signal. So from this continuous signal, you will do the digital analysis, and then you're going to use the digital assignments, and lastly you will get this. It's not, I didn't see any type of question that may ask you what is the step for you to convert. As long as you know there is two converter from analog to digital and digital to analog, is called as analog ADC converter, analog digital converter, and also DAC digital analog converter. But we will see it in next slide. So this one is another example similar to this one. Okay. Aduh. Muhammad Imtiaz. Muhammad Imtiaz. We cannot hear you. Where's your camera? Cannot hear you and we cannot see you. I didn't respond because I was in toilet. I can't open microphone. And then you cannot also turning on your webcam. It's okay. Next time, please log in using your phone if let's say you have any difficulty using microphone and also your webcam. Okay. Let me ask Khairul Izul.
Yes, madam.
Okay. Let me ask you. Which one is analog?
Which one?
Yeah, which one is analog?
Is there any photo?
Huh?
Wait.
Wait.
Is there any photo? Okay.
You cannot see I share my screen.
Cannot yet. Okay.
Huh? Wait. Why is pause?
Pause.
Doctor, you're sharing the slide, but just you have to shift to that slide, so it's able to see.
I already shared the slide.
Yeah.
How?
Can see already.
Yeah,
Okay.
now I can see already.
But I think just now, okay. It is. Then it's okay now. I think a delay. Okay. Now, which one is analog?
I guess C and also E. C and E. Yeah.
This one and this one only.
Maybe A. A.
So you have three answer.
The A one I'm not confident with the answer, but for C and E, yes.
Okay. All your answer is correct. So over here for the analog one, thank you for answering. Okay, you can see over here. Okay, this is analog. This is analog and this is analog. For the clock, this type of clock, it can be easy to like differentiate because digital mostly look like a numbering like this, and your value not going to continue. You will like have at least 1 second, but for the this kind of clock is continuous. And for the phone, if you want to dial using this smartphone, you need to like press your number.
同行别打，
Please turning on the.
还有人放个炮台是什么意思？我们两个，我讲我很好奇，你放个炮台是什么意思？
Okay.
我讲你放一个炮台是什么意思？
Why after I log out from here, then you turn on your microphone.
Sorry.
Okay. You can see over here, let's say you have the keypad, right? To like dial your phone friend numbers and so on. You can like press 3, press 2, press 1. But if you want to use this one, you will like put your finger here and then you will like drag until here and then another time, another one more time for dialing. So maybe because of this, it called like continuous. But for television, I don't know how to differentiate it. Maybe when we like saying, okay, this is new brand. So new brand is digital. I don't think so, but I think it is inside of the system because I have also this type of television, but it is not digital. For me to use digital, I need to like use the converter. So maybe also in the type of the picture, it look like digital because it's like camera digital and so on, right? So I don't know how to differentiate this, but this version is the digital one, and maybe on the color itself. Do you have any idea how to differentiate television? Maybe because this one is bigger or what type? Or maybe this on the button. Because this one, if you want to change, you need to like press the numbers also, right? But if you want to dial and change your channel, you're going to use this. That's why it's called as analog. It's continuous. So if you have like any idea how to differentiate between these two television, you can share with us. Okay, but this is the correct answer for the analog system. Okay, this is another example which is on digital system. You can have the similar like your watch over here, but it is a digital form. You can also like have the phone at your house, but it is in terms of digital. and another television, but you can have like a remote and you have like keypad to just key in. So no need to use any kind of analog versions of button. So over here, there is also another example where you're going to apply for your digital and where you're going to apply for your analog technology. And for this digital, you can apply in like computer, manufacturing, science, and etc. You can like just go through. And in this world, basically, including ourselves, a human also, we will have the advantages and disadvantages. We will know that although ourselves, maybe we say, okay, I'm a perfect person in this world. There is no such thing like that. Because of this, we will have advantage and disadvantages compared to, no need to us to mention about prospect and so on. Okay, so digital advantages over here, it easy in design, easy to use the storage, accurate and precisions. So you can read through what is the advantages. And normally in a question, it will like ask you, it give you several maybe like question, what is advantages of digital logic, and then you were given with 1, 2, 3, and then there is ABC, maybe 1, 2, B is 2, 3. So you need to know the advantages, then you can answer the question. So please make sure you know what is advantages. And similar to human, every single thing in this world got also disadvantages. So the disadvantages for the digital is it require a huge in bandwidth. So bandwidth require for digital is quite big. And then while you need to like convert from your analog signal to be your discrete signal, is going to also have an error while you want to convert it. And then compatibility, because sometimes there is a need for you, maybe like me myself, let's say I want to use a display for my computer, so I want to have like something else to connect to. But if let's say some is analog, another one is digital, so you need to have the compatibility version between each other. So that's why you need to also have a problem later on. If it not compatible, you need to have like a converter and etc. And the much more easy for you to remember is on the half-life time, product half-life, which is, we can see the very easy way to differentiate is on a mobile phone. Although last time it's like very big in a mobile phone, and currently we have very slim versions of phone, but throughout this version, which is digital one, is can easily been broken, and then like maybe it can be used only 1 to 2 years. But your it's very ugly. Your phone, the older version, which is analog version, maybe it's going to took like maybe 10 years and longer. Similar to your television. Sometimes if your grandmothers, your grandfathers still have this huge television at home, you will see that it still can be used. So it's very long lifetime if compared to our digital version now. Normally it will give you like 3 years warranty. After 3 years, one day it will broken, something like that. So very short in lifetime. That is the very big disadvantages for the digital. In one system, you can have the possibility to have two systems together, which is you can have analog and digital in one time, in one system. So over here you can see this is example when you want to play like a music. You have the disc. This is the CD compact disc or CD. So this CD is digital. Although normally you can say, oh, this one is look like a circle. Circle normally like analog version 1. But when you go to COA subject, next semester you will take this COA subject, which is computer organization and architecture. So in this subject, you will look at CD, basically how you're going to store the data inside. Is there is a segment inside this CD. So in this segment, you will have 0101, 0101, 010101, whatever data that you save. So altogether, you will like have 010101. So it's not analog. It's not analog, and the way you save the data is all in a digital form. So that's why you have the digital CD over here, and then you use the CD player. CD player will play, and then it will like convert your whatever data that you save here, and then it will convert into analog wave. The one that you heard, and the one that you hear about like music, although my sound, my voice, all is analog wave. So this is the example. When you have CD drive, you put into the CD player. Inside the CD player, you will have digital to analog converter, and then you're going to reproduce it to be analog signal. And of course, maybe you said it is not really clear, and then you want to increase the volume, then you're going to use the amplifier or speaker later on to increase the value. So last time I don't know what is hybrid means. Hybrids mean at least you have at least two combination of method or approaches or system in one. So you combine, let's say you have like 2 in 1, 3 in 1. So we can call it as hybrid, at least 2. So over here, we can have hybrid system by having two combination of analog and digital. So we have the hybrid system for our CD player. So by just playing your CD in your car, and then you hear the music, so it can call as hybrid system. Then you can say to your friend, okay, I want to use my hybrid system. Then what your friend was like, huh? What hybrid system? Oh, I'm going to play my CD, and then I'm going to hear the voice, which is analog voice. Then maybe your friend will be like, gila ke? So as long as like you can apply into your real life, then maybe you can like show off to someone that don't know, right? Why don't you can like having a scientific name for any kind of system using like hybrid system, rather than you can just say, okay, I want to use my CD player, I want to play and hear music. Okay, back to over here. You can see, as mentioned previously, you're going to have only two type of converter. You're going to have analog to digital converter, or another one is digital to analog converter. What is the function for analog to digital converter? It's going to convert when you have the analog wave, you convert to digital. And then for digital, it's convert to analog. How it's going to be look like? So let's say you have a microphone. Okay, you are a singer. You sing. This is, you send your analog voice. And this microphone are connected to the radio system. And then this radio system are connected to speaker. Is it like this? It will connect to speaker, and then there is your voice after converting into the player, the system, and then it will convert back from analog to digital, and then from digital to analog. So this is your voice after being into two type of converter. That's why you can have multiple of converter inside one system also. So is there any question about analog and digital? Well, okay, sorry for the interruption. Let me continue. Okay, that is on your conversions, digital and analog to digital, vice versa. Maybe I will open. If there is no question, because I said it's quite boring to just like learn on theory. Now we're going to look into the way how digital. Now we will look into only digital. So what is basically the logic level on the digital waveform, how it look like. Okay, over here, you're going to see that you will have this kind of waveform. Okay, where is it? Okay, this is kind of the waveform. And you will have only 1, 0, right? As I mentioned, there is no in-between value. Similar to this part, you will have 1 and 0. Between, there is nothing. You're not going to have any kind of value in between. And I already also mentioned to all of you, if it is 1, it is high, it's similar also on, it also like true. What else? Then this one is off, false, and etc. So as long as you understand like the positive versions, negative versions, and in terms of this value, you will have 1 and 0. This is 1, this is 0, 1, 0, 1, 0. You need to know the basic understanding on how the value will represent. If not, later on, if you want to like draw the timing diagram, it's very hard for you. But I think it's very easy for you to understand because you have only two possibilities, either 1 or 0, isn't it? So you will not have this kind of version and you only have 1 and 0, high or low. You can read all of this basically is similar. And we call these as pulse. You can see digital waveform are made up of serial pulse. Let's say, what is the meaning by this? Okay, you're going to have this kind of pulse. Is it digital waveform or not? It is not, because you only have one pulse. But when you have several pulse together, maybe like this, basically the higher is similar. Okay, this one. Only I just want to show you like it is big and small. I really bad in drawing. As long as you have several pulse, 1 pulse, 2 pulse, 3 pulse, 4 pulse, so it's combined together, we call it as digital waveform. And there is another keyword that very important and you need to know, which is at this. You will go to next module, but don't forget about this one. A positive going pulse is one that goes from low to high. It's like, oh, it's quite easy. So you can see over here from low, you have like 0 and 1. From low to high, we call is as positive pulse. When you have another one, which is from high to low, we call as negative pulse. Or let's say, normally you can, there is a student ask me, is it always the pulse starting from 0? No, you can also have this kind of pulse, which is starting from 1. It depends on the question. And another one more thing about the positive and negative part, which is you will have this kind of arrow. This arrow will be pointing up, which is from down to up, and you will have the positive clock or positive pulse. But why I said clock, later on you will learn about clock, and sometimes you will not been mentioned. You will not been mentioned. This is positive clock. You're not going to be mentioned, but in the diagram it will show like this. So you need to remember, oh, this is positive pulse, then you need to do this and this, because there will be a certain criteria. If positive pulse, then your output will be like this. If negative pulse, your output will be like this. So your negative pulse, you cannot draw the negative pulse here, although like supposedly it at the same place, only it's pointing different way. No, because our waveform will be from left to right. So negative pulse will be putting at this part. It's like, isn't similar, doctor, because it's pointing the same, but no, this like pointing from up to down. From up to down, it will be negative. Although like you said, isn't it similar? But as long as it's pointing up and another one is pointing down, if the it's pointing down, means that it is negative pulse. It's not going to have two. If let's say you have this kind, then you have these two. No, you're going to have only one. If let's say it is positive pulse, it's going to show like this. Your waveform will have this all arrow at the positive side. If it is negative pulse, then it will draw like this. So there is no casting that you have both. Sajat dia ada both. So there is no casting in this world that we will have two in one time. So we will have either positive pulse or maybe either it is a negative pulse. Okay. Over here, you can see this is the example of positive or active high. This is the one that I mentioned. Sometime in question, it will inform you that it is a positive logic, or maybe it don't want to use this term, and maybe it's just active high. So you know that high is positive, and high is normally 1, and high is normally on, and high is true. So either of these term, you will know that, okay, this one is a positive going pulse from low to high. And then the value of high is 1, and the low value is 0. It will be vice versa, okay? For the negative low, also active low, the high will be 0 and the low will be 1. This is the value, not the value of like this one is high, over here is 1. And the value of when you apply into several method later on, you will notice that you're going to use high as 0, low is 1, if in the case of negative low, active low. Next module, I forgot what module. You will found this, we will repeat again this part. So it's quite similar, so no need for you to worry, only that it's good for you to remember from start. And this is the look like for the pulse negative going, which is from high to low. If you have any kind of question, just interrupt me, okay? So next, this is how it's look like. You can see that you need to differentiate between high and low in terms of symbol. You're going to have a clock. Later on, you will play with a clock in your gates and so on. So this clock, sometimes you will find there is a bubble. So let's say because we still not yet learn about clock, we still not yet learn about gates. So over here, it is more to block because don't want you to confuse, right? So when you have a bubble over here, it's mean active low. Or again, you mean like from high to low. And then if active high, there is no bubble. So you need to know between these two because in the question sometimes it's not mentioned in sentences. Instead, it's just give you the picture without any explanation. So you need to apply certain method. If high, what is the output? If active low, what is the output? As long as you know, okay, this one is active low, this one is active high. Okay, this one is digital waveform. Aduh. On digital waveform, there is two type of square waveform. Only two, okay? There is no three type. So over here, you can see the two type of square form is parodic and non-parodic. Parodic means it will repeat. It will repeat. Although, okay, I give you example how it's repeat. Let's say we're going to have this kind. Hope that I can draw it clearly. Although you said, Doctor, this one is small and then this one is like a bigger and then small is bigger. It is not repeated, but you can see there is a sequence. If you see clearly, this one cycle or one pulse, one cycle, and there is another one. There is another one is repeating. So it's still we call as periodic. And for non-periodic, you cannot find any repetitions in the pulse. So this is the first differentiation between periodic and non-periodic or aperiodic. For periodic also, you're going to have the period or the T. This you already learned in your physics in your secondary school. Frequency equal to 1 over T. T must be your period. And this one is your frequency. And the units will be hertz. For a period, the unit will be second. So this is the equation that you might apply in terms of our waveform.
It's 15 hours.
So you look over here, in this example, you're going to have this as a period. Okay, the one that I draw, why I delete, the one I draw, also got period. This is the period. 1, T1, and then it continue, it will be T2, and repeating. So same goes here. It's starting from this point until this point, and then it will repeat again. It will be another period, another period. This is an example of periodic signal on the sine, square, triangle, sawtooth, and although you have many type of signal, you can see that in our digital logic subject, we only like focus on this square signal. And while our periodic signal will be look like this. Okay, from here, this one I already shared with all of you about the equation. Now let's take a look. Okay, before I go deeper, you can see this is the equation that normally we will apply in our waveform. And when you're going to see your waveform later on when you come to UTM, you can see there is also oscilloscope for you to see all the waveform. And you can change the type of the waveform also. And you can apply if let's say you were given the value of hertz frequency, find the period, or maybe you can also have the period, find the frequency. You can play with your friends, sharing any kind of value and ask them to answer. Okay, on unit conversion, please make sure you remember, because in our test, we will ask you definitely on numbering. Although it's just a simple conversion, let's say I will ask you a simple question. 197 is my favorite number. And what is the equivalent to this number? You are given A, B, C, D. Maybe first they give you 0.179 giga, or maybe 1.97 tera, 19.7 pico, or maybe 197 times 6 nano also, or maybe milli. So what is the correct answer? This one is I just give example, okay? So I don't know the answer. Lazy to calculate, but this is the kind of question that also can come up. Although it's just a simple value or simple question can be asked, but in terms of if you cannot remember what is giga, how you going to convert like 197 times 10 to the power of 6, and then there is another milli. What is the meaning of by this? So if you don't know how to convert, then you must be in trouble, because you cannot answer this 1 mark question. Maybe you say that, it's okay lah, 1 marks. No need for me to answer this question correctly. But with 1 mark, you can change your grade to be positive A or maybe A. So please make sure whatever question you need to carefully answer. So please make sure you remember all these unit conversion. Okay, and play around. Always do exercise. Now it's go like into more to mathematical terms, which is when you have the frequency here, you need to find your period. How are you going to find your period? You can see it's give you directly the unit. So you have 100k. What is the meaning by k? So you will know that, oh, it will like time with 3. I also forgot already. It's will time with 3. So when you time with 3, you will get 1, 1, 2, 3. And for this part, because of this is frequency, to get your period, you will like divide like this. So that's why you will get 0.000 1, 2, 3, 4, 5, 1. So you get here. So now how you going to like convert back to your units to make, let's say, 1 millisecond or maybe 10 millisecond or 10 microsecond. So this is the way in the mathematical terms, so how you're going to convert. So from here you can see you will have this one which is similar that I show you on top, and from here you will get the value of 0.01, and then you will times with -3. Why it's -3? Because it is below. Why is 0.01? Because you divide it with 1 per 100. If you divide, you will get 1, 2. That's why you get 0.1. And then you will time with 10 to the power of 3. Because it is divided, you will get -3. -3, you will get 0.01. This one is millisecond. If you check back, this one is millisecond. And how you're going to convert it, you can like go to 1, 2, and then there is another 1, 3. Then maybe you can like have 1 microsecond. You can also like stick with this answer, but sometimes maybe you need to have like finish it until you get the whole or your integer number rather than using the fraction number. This one is fraction number, and this is a whole or also digit number, integer number. Any question on this? This one is only a mathematical, and this is the equation that you already learned in your secondary school. There is another example. Please make sure you try. You can screenshot. Wait, I think I already record. Okay, you can like screenshot this answer and try. And there is also another. So this is more to mathematical, and please make sure you change the value instead like using only 1. You play around with this value 5, 3, 4 maybe kilohertz, and then you pass to your friend, then your friend answer, and then your friend also pass to a different kind of numbers, just to make sure that you familiar with uh the conversion. Now you go to the pulse definitions. Although over here it shows you like analog signal, you can see that there is a rise time, there is a pulse width, and etc. This is just for you to see in terms of analog version. But normally there is only a few with our square. You need to know about amplitude. You need to know about pulse width and also period. Period, normally we will use T. Pulse width, we will use TW. And our amplitude will be A. And on top of all this information, you will get duty cycle. What is duty cycle? Duty cycle is a ratio of TW to T. So let's take a look. Times with 100%. So let's take a look at an example. You were given, this is the example, okay? You were given with the pulse width 1 millisecond. So I'm going to find my duty cycle. My pulse width is 1 millisecond per 10 millisecond. times with 100%. So this is the one that I will see. And you can see your answer will be 10%. Okay, what is the meaning by this? Normally, for duty cycle, because it is in terms of percentage, it's going to have 100% altogether from for your period. For your period, you're going to have 100%. So for this pulse width, your pulse width or your TW, your pulse width, you calculate, you were given only 10% over here. So you will have another left over here, 90%. Or maybe you can see this one is 1 millisecond, and of course this will be 9 millisecond. Why I said so? Because you're going to see also another kind of different example. Please determine the on state. Please determine the on state and off state. Now you can see, oh, just now I will be teach with using the pulse width. This is pulse width. Where is on state? As I mentioned, on is positive, on is 1, on is false, true, on is high. So it will be here. The state of here is on state. And where is your negative state? Your negative state will be at this part, which is low. So this is your negative state. Let's take a look over here. You were given with period. Okay, now your T is given 1000 millisecond. You need to determine your on state and off state. Your duty cycle already given. Okay, let me see. As I still remember, my duty cycle 25% equal to my duty cycle lah. Duty width. Pulse width. Okay, my pulse width is TW, or maybe it is on state per 1000 millisecond and 1000 millisecond time with 100%. So this percent I remove already, and I will bring this up. It will be 25 thousand millisecond equal to TW times 100. 100 I will remove, and then I will get 25 200 millisecond equal to TW. So this is my TW, and I think my pulse will be look like this. This one is 250 millisecond, and my T already given 1000 millisecond, and my off state must be 750 millisecond. So my answer, I want to tell my lecturer this is my answer for my on state, and this is my answer for my off state. Is it correct or not? Let us check. So this graph is not given. You were given only sentences. You play around with the equation given. You can see you get this value. This was given. This is on state. And this is off state. Okay, now I'm too tired to teach. Someone please help me. Taking my place. Prepare to share your screen. Muhammad Akasha. Because I cannot see your face, I only can see your firework.
Yes, teacher.
Okay. Can you answer this question? Not answer. I want you to teach us. You screenshot, okay? You screenshot after this. Okay. Screenshot this question and then you put somewhere in your words, in your pen, or in your Padlet, in whatever you want to use. And then you share your screen. Okay. Finish screenshot. Done, yeah? SS.
Yes.
Okay. Okay. Now the floor is yours. Akasha, did you share your screen? You cannot see. Tiba-tiba dia tutup mic pula. Akasha. Oh,
Wait.
Akasha.
I want to set up my WPS writer.
Okay. Okay, well then maybe you can like go and find the drink. You can like have a break while waiting for Akasha. Teach us.
Doctor,
Yes?
can I ask a question?
Okay, sure.
Does the pulse width only consider the on state of the waveform?
Yes.
Just the on state only.
Because it's like pulse. Pulse means it will be like something that trigger from off to on.
Oh, okay. Thank you, Doctor.
It's not going to go to down. So pulse will be up.
Thank you, Doctor.
Okay. While waiting
Teacher,
for Akasha, yes.
may I answer the question first?
Why? I don't want to. I don't want to know about the answer. I want you teach. I want you to teach us. The most important is on the step, not on the answer. Your answer normally will take 1 mark only. For the step, it will more than like maybe 2 or 3 marks. Okay, while waiting for Akasha to set up, bye. Okay. Kak. Bye. Okay. While waiting for Akasha, maybe we can like have just borak-borak kosong. Let me like ask Muhammad Rizwan. I cannot see your face. Where are you from?
Hello, boleh dengar kau?
Boleh.
Good afternoon.
Hi.
Hi. Apa soalan tadi?
Soalannya you dari mana?
Oh, saya asal orang Utara, Penang.
Oh, ni. Hari-hari makan nasi tak?
Makan. Masak, ada kala masak sendiri, tu je lah.
Tidak. Okay, masak sendiri. Lepas ni,
Ah.
mungkin you boleh masak lah untuk you punya roommate nanti bila datang UTM ni. Selalu menu
InsyaAllah.
apa? Menu apa yang paling best lah you pernah masak?
Most of the time, saya masak mi lah. Tapi
Baru
ada
nak cakap
kala-
dekat semua perempuan. Baru nak cakap kat semua perempuan ni, okay, this is your future husband.
tapi adalah kadang-kala saya masak sup sikit lah, tu je lah.
Oh, so you pakai sup bonjut ke you pakai tambah garam je?
Ada macam pakai apa tu, yang perencah, buat sup ayam, telur apa. Kalau saya rajin, saya buat lagi sedapnya lah. Kalau tak, saya masak biasa je lah.
Lagi sedap tu apa?
Entah, saya tak pernah buat lagi sebab saya selalu malas sikit nak masak.
Aduh, dia kelakar lah. Okay, thank you Rizwan. Ni Muhammad Zul Nizam. Nampak rambut je. Where are you from? Di mana Akasha ni pergi? Nak set up bukan main lama ni nak lupa.
Sungai Buloh.
Sungai Buloh. Dekat Sungai Buloh tu, kedai apa atau makanan apa yang paling best?
Sungai Buloh tak ada makanan yang sedap. Kena pergi Penang baru sedap.
Jauh sangat. I tak rentah negeri lagi. Dekat Sungai Buloh, I rasa ada satu kedai Shell Out. Saya selalu pergi situ juga.
Tahu.
Tak tahu.
Tak tahu.
You memang jenis makan kat rumah je lah ni.
Makan rumah je.
Siapa masak?
Mak masak. Saya tak kerti masak. Masak nasi reti lah, tapi mi tak reti.
Mi tak reti?
Tak reti.
Maggi pun tak reti?
Maggi boleh lah. Rebus 3 minit siap lah.
Akasha ni cenoneng ni. Ya dia pergi nak set up komen lama. Lepas ni mungkin kita tengok dia punya slide gerak-gerak ni. Lama betul dia nak share screen. Okay, thank you Zul Nizam. Nak panggil Zul ke Nizam?
Zul Nizam tu nombor bapak saya saja. Tahu Google ni dia pelik sikit. Nama saya Muhammad je.
Oh, you punya nama Muhammad je eh?
Panggil Muhammad boleh.
Tak ada lain?
Tak ada.
Muhammad bin Zul Nizam.
Muhammad bin Zul Nizam.
Okay. Senang
sebab
sikit.
last name first name tu kan.
Nama panjang sekarang ni masing-masing. Saya pun pening. Okay, asyik lelaki je kita panggil ni. Nur Maziah. Where are you from?
Saya dari Sungai Petani, Kedah.
Oh, dekat dah dengan Penang tu. Sungai Petani, Kedah. Best mancing. Pernah pergi mancing tak?
Pernah.
Mesti selalu mancing kat Bendang. Dekat Sungai Petani selalu pergi mana je?
Selalu pergi Aman Jaya Mall.
Ada kat situ SP apa Saya dah ingat dah. Saya dulu daripada Matrik Changlun. You matrik mana?
Matrik Changlun.
Oh, siapa yang ada kat situ lagi? Tak ingat lah. Siapa lecturer yang you kenal, you ingat?
Madam Marzita.
Marzita ajar apa?
Sains komputer.
Dulu kita orang tak ada sains komputer. Dulu kita ada bio dengan fizik je kan? Dengan accounting. And ada kenal lecturer daripada fizik ataupun kimia?
Kimia, Madam Faizi.
Faizi tak kenal. Kenal Encik Fazirul tak?
Ada.
Kaila, Alah, I also dah lupa dah. Tapi saya after I finish like my master also I go to matriculation just to meet my lecturer there. Akasha tak habis-habis lagi ke setting? Okay, thank you Nurma.
Dan teacher.
Just share your screen.
Do you see my presentation?
Yes.
So the question is given the duration or period of a system is 1000 millisecond. Then determine the on state and off state of the system. Then operate with the ratio of duty cycle is 50% and show your works. So to find the on state is equal to duty cycle. So to find the duty cycle, just use the duty cycle formula, which is duty cycle multiply the period. So 50% multiply 1000 millisecond. So the answer is 500 millisecond. So the answer for on state is 500 millisecond. For the off state, just period minus on state. So the answer is 1000 millisecond minus 500 millisecond. So the off state also 500 millisecond.
Done.
Yes.
Okay, thank you.
You're welcome.
May I ask Jin Wayne?
Yes.
Do you find any wrong from Akasha explanation?
I think no, because it's because it's same with my step.
Okay, thank you. Teo Jo, I already asked you. Okay, sorry. Gan. Hang Lai Gan. You
Yes,
find
doctor.
anything wrong here?
Anything? I
Yeah.
see no problem.
Aduh. No problem also.
Let me check again. Go.
First line is it?
The 50% time 10,000 is 10,000. Yeah. The second line, the 50% time 10,000 millisecond.
1000 supposedly.
1,000 supposedly.
Okay. Nampak tak Akasha?
Sorry, I cannot understand.
Buka you punya words tu. Okay, pergi dekat 50% tu. And then there is okay, another one. Lee Chin Hong. From this explanation, is there anything wrong?
I think everything is fine. Yes, doctor. Can you hear me?
Yes.
I think everything is okay.
Okay, thank you. Next person, Amalia Shazana. Is it correct or is anything wrong here?
Hello.
Yeah.
I think it's correct.
No, nothing wrong here.
No.
Sedih, I nak nangis je ni. Muhammad Afiq Haziq. Is there anything wrong here?
Yes, better. I think everything is okay.
Cepat, siapa boleh jawab? Ada apa kesalahan kat sini? Anything can pointing out. Kasha tunjuk je lah you punya words tu.
Alright.
Doctor,
Yeah?
maybe the duty cycle is not same with on state.
Yes. Finally. Duty cycle is not equal to on state. Although you have like correct answer because you understand the step, but it is not on state for duty cycle. Duty cycle is the ratio. Faham tak Akasha? Kat situ.
Okay.
Itu je dia punya kesalahan. Okay, thank you Chen Hong. Finally there is someone that can find what is wrong. Okay, thank you Akasha for your explanation.
Okay, sorry for the late.
Okay. Now let us continue. Where is my slide? Okay, just now Akasha did mentions that duty cycle is equal to on state, but basically on state is equal to pulse width. Okay, so pulse width which is on state. So in the equation, you're going to see after this. Akasha dah boleh tutup mic dah.
Oh, sorry.
Okay, this is the Akasha equation. You're going to see the basically is similar to what Akasha explained to us, and in this question it will directly give you the sentences without knowing how the signals look like. So when you got all this information, like what Akasha told us and teach us, you're going to draw your own timing the signal. Next question is going to be basically similar, but you can see over here, this is the kind of question that you say, okay, quite simple. But when you go to here, okay, the question is quite long. But basically similar, only like in terms of we put A, B, and you were given the duty cycle instead in previous question. You were given with duty cycle and also your duration. But in previous question, you've been informed about on state. In this question, is directly ask you pulse width. As mentioned before this, as long as you understand what is pulse width, what is the look like of on state, then you know where to apply and to find the value. So in this question, basically similar, like you need to find the TW, which is your on state. Please try to do this question, and the period will be given over here is 500 millisecond. So your on state is getting this value. Lastly, your off state is 300 millisecond. So you have 3 example question, although the step below is similar, but in representations you can see just to make you a bit confused, so it's changing in terms of the names. Okay, now I have this waveform. Uh, Nabil, because dari tadi dia tak buka lagi kamera dia. Nabil, can you answer me this question? Nabil, are you here?
Yes, Doctor.
Okay. What is the value? The question is, what is the value of A, B, and C at T3? What is the value of A, B, and C at T3? Where is Nabil? Nabil, where are you? My phone is running out of battery, so if you WhatsApp me, I'm not going to receive, okay? So Nabil, what is the answer?
What is the value?
Yes.
One.
Okay, so Mama just try it up. I don't really look.
Doctor,
What? Yes.
value is 1
What value?
for A, B, C.
A, B, C, all is 1.
Yes.
Okay. So thank you, Nabil. Let's recheck the answer. Is it correct or not? Before that, anyone can just inform me, is Nabil answer is correct or not?
Adik penat main dekat luar.
You penat-penat pergi baring. Anyone? Is it correct or not?
Nanti mau susu.
No, Doctor.
Yes?
No, Doctor.
No. So what is the answer for your answer?
110.
110. So which one is the correct answer? So let's take a look. This is our wave for our clock. There will be T1. This one is small t. This one is small t. Normally we will start at 0 or 1. I forgot already. See, 0, 1, 2, and etc. So this is our T2. This is our T3. So normally it's not going to ask like T3 without informing where is it, but I just ask because I just want you to know that this is period, and normally it will ask you a period at certain part. Okay, for T3 it's going to be here. It is not at this point only. It is not at this point only. Instead, it will be here all. So for all this, you're going to see A will be 1, B will be 1, and C will be 0 because it is at the low. Okay, thank you for answering this. I cannot see your name, sorry. So, and you can see this is how the timing diagram look like. And normally, this clock sometime will be at bottom part, sometimes they want to put up, depend on the question. So as long as you know, okay, what is this? And sometimes we already mentioned, okay, A is the output, input, B also input, C is the output. Or maybe you were given with these three input, what is the output for all of these? With the combination of, let's say, get or maybe a combinations of get and. So your output will be X. So how your X will be look like? So you need to draw. So this is, I guess there is one wrong of here. So this is the answer. So supposedly you have like 1, 2, 3, period, and so on. So as long as you know, then it's easy for you to answer. This is very basic for you to look into the timing diagram. You can see when you reach at the T8 or period 8, all the A, B, C will be 0. And the value of all these A, B, C is going to be vary, okay? Because there is also student ask me, is it must be the same for the output, or maybe at the end of clock 8, it will be similar, which is all 0? No. This one is just example for you how to see this timing diagram. Of course, these all input and the output will be different, especially when we ask you a question in test and final exam. Okay, this one is also similar. You can see only that maybe this error can like pointing out to all. So it is cover everything here. So what is the value? You can see sometimes you can also like informing in term of 1010. Sometimes it can like mention is high and low. So over here, you're going to see later on, you're going to see a table. We're not going to ask you, please draw a table. No, instead we're going to call it as a true table. When you have the timing diagram, you can use this timing diagram and draw your own truth table. Sometimes we were given you with a truth table, then you need to represent and draw the timing diagram. So vice versa, you need to know. Over here, if you were given with this timing diagram, what your answer, let's say on the clock 2, you will have A 0, 1, 0. So 0, 1, 0. So you can fill in by yourself because it's very easy for you to just fill in. And lastly, before our end of this subtopic, you're going to see there will be a several way for you to transmit a data similar to your torchlight. If you have like torchlight, again, I'm not really good in drawing. So if you have torchlight, you can see that there is a way for you to put battery in. But sometimes there is also a different kind of torchlight. You're going to see that the battery need to be put in this kind of way. So what is this and this? This one is more on like circuit. So this is serial and this is parallel. So serial, you're going to go directly like 0, 1 continuously, like serial way for you to transfer the data. While for the parallel, you're going to send one by one together. So there is also example where you're going to apply serial transfer, data transfer and also parallel data transfer. So I just only that. Later on, you're going to see on basic gates. Let me see what time now. Okay, let me go directly. I think so. Because I don't want to be like quite late. Your another section already at module 2. So over here you can see we will play around with our logic gates. It's very fun because you will play around with electronic device. But of course, you're not going to see it because you cannot go to the lab. You can play with these all software, all things using this DIT simulator. So please try to install and play along with all these DIT things. So now, before you go deeper into having the circuit, a combination circuit, sequential circuit, you need to know a very basic gates. So there will be only 3 basic gates. Sometimes in question, they're not going to inform you. They just like, okay, please choose where is the basic gate. So if you can't remember that basic gate only have 3, then it will be hard for you. But if you still remember, okay, I remember there will be 3. But if you're lucky, the question will directly inform, okay, what is the 3 basic gates? So you need to know that the basic gates is AND, OR, and NOT. Easy get for you to look into is NOT get. For NOT get is also similar to opposite or inverter. It will invert any kind of value that you will fit in. But of course, you only have 2 choice, 0 and 1, because we can only use digital using our gates. So either it is 1 or either it is 0, it will invert. The output will be invert from the input. So this is the characteristic of gate nodes. And normally the minimum and normally for the NOT gates, it will be only 1 input and 1 output. And you can see sometimes it's at the left and sometimes it at the right. It's depend on the question because you're going to apply this bubble thing later on in the method for you to minimize your complex circuit. Okay. As long as you know that, okay, if I have bubble over here, similar to your T life, there is a lot of bubble, so it is negative because it's not good for your health. And over here you have AND gate and OR gates. For AND gate, you can see there is like, wow, there is 4 input maybe. This one also 4 input. You can have many input as well, but your minimum input must have at least 2. At least you need to have 2. Then you will have 1 output for the AND gate. So for the AND gate, it is going to be characteristic as true if all the input is true. Let's say I have here 0, 1. So what is my output? Oh, it will be 0. Why? Because I need to have all 1 only, then I will get 1. So if let's say I have like 5 input, all is 1 unless one thing that is 0, also I will not get 1. Instead I will get still 0. Unless I get 1 all, then output is 1. Okay, this is the characteristic of AND gates, and it will be look like this. And now, okay. Okay, bye. Okay, you can see over here, you have O get, and the different picture, you can see there is a curve like this, and the minimum of input will be 2 input only. So what is the characteristic is it's going to be true only if at least one or more input have the input condition as true. As I mentioned, true is 1. So at least 1. If let's say I have like 0, 0, 0, 0, and then suddenly I have another 1, I still get 1 as my output. So this is the condition of gate O. Let's take a look here. Okay, bye. Okay, you can see over here, this is logic gate not. Why you have only these two conditions, 0 and 1? Because you only have one input. That's why you can only have 0 and 1. To the power of 1 will get 2. So there is only 2 possibility. So this is the equation. If you have this number of input to the power of 1, you will have 2 possibility. Let's say for your AND gate. For your AND gate, you have 2 input, right? Maybe I put it. For your AND gate, you will have like, let's say, 2 input. If 2 input, how the condition will look like? So you can see 2 to the power of 2. Why it's 2? Because there is 2 input. So I supposedly have 4 possibility. What is the possibility over here? I can have, let's say this is my input A, my input B, and this is my X for the output. A, B, X. I can have 0, 0 as the input for my input here. And then my condition will be 0 for X. And then maybe I can have 0, 1. I can also have 1, 0. I can also have 1, 1. So there is possibility 1, 2, 3, 4. I cannot have another. All I already covered here. And what is basically 0, 0, 0, 1, 1, 0, 1, 1? In binary, if you convert to decimal, you will get 0, 1, 2, 3, and so on. Okay, this is 2 condition. Let's say I have 3. I have 3, and then I need to check what is the possibility scenario that I have. So I should have 8. So let me see. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is the condition that you can find if, let's say, it is 3 inputs. When you have 3 input, you have 8 possibility. And as mentioned, what is basically the value? It will be 0, 1, 2, 3, 4, 5, 6, 7. Later on, we will learn how to convert the value 111 to be 1. This one in decimal, this one in binary. So I guess we're going to continue later on to be more deeper in the next gate. just now, you just learn on the basic logic function, which is you have three basic gate, AND, OR, and NOT. So any question? So if there is no question, we will end our class for today. Thank you for your participant. Tomorrow we have class 8 a.m. right? So we will continue our logic gates, and then I think we will go to the module 2, because there is a part that I'm going to do as asynchronous, which is on the marks, the marks. I want you to read from your module books, and I will provide with the video for you to watch. Okay? So if there is any question, you can WhatsApp me. So meet again in our next class tomorrow. Don't forget to scan your QR code, okay? Okay, bye-bye.
Thank you, Doctor.
Okay, bye.
Thank you, Doctor.
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 Thank you, Doctor. Bye-bye.
Bye-bye.
Thank you, Doctor. Bye bye. Good afternoon.
Okay.